In this practice, a photon with wavelength lambda scatters off a free electron and produces a second photon with wavelength of the lambda primes. The second photon scatters off another free electron and produces a third photon with a wavelength of the lambda prime primes. If the third photon moves in the opposite directions with respect to the velocity of the first photons, calculate delta lambdas. So lambda prime prime minus lambda. The mass of the electron is 9.11 times 10 to minus 31 kilograms. So in this case, originally lambda is coming and the electron is scattered these directions, and photon is scattered off is this direction with the lambda primes, and the photon is traveling and they meet another electrons, and the electron is scattered in these directions and the photon is scattered in the opposite directions. So this is lambda prime prime. So this means this should be the thetas, because these two lines have to be the parallel. So this is thetas. So this is gonna be pi minus theta. So we could use we derived lambda prime minus lambda equal h over mc 1 minus cosine theta. So in the first collisions, lambda prime minus lambda is gonna be h over mc 1 minus cosine theta, because the scattering angles of this case is a theta. You can just substitute theta. And the second collisions, second interaction. So lambda prime double prime minus lambda prime is going to be h over mc 1 minus cosine pi minus theta. So in this case, scattering angle is pi minus theta. So you should substitute pi minus theta. Then you could calculate. It's gonna be h over mc 1 plus cosine theta. This is the first scattering and the second scattering. And in the questions, we'd like to find out the delta lambda. Is a lambda double prime minus lambda. Then in this case, you can just calculate 1 plus 2, equation 2. Then lambda prime is going to be cancelled out. Then cosine theta is also cancelled out. So this becomes 2h over mc. So you can substitute Planck constant and the mass of the electrons and the speed of light. Then you will get 4.85 times 10 to minus 12 meters. So change of the wavelength is 4.85 times 10 to minus 12 meters. This is the answer to this practice.